All right, everyone. So yeah, we're going to be doing a really quick crash course on electronics. This is hopefully only going to last about an hour, or like until lunch, whenever that happens. But we're mainly going to be going over some basic stuff with parts, some assembly stuff, and mostly edit in context, since that's a really big one for electronics. All right. So it sounds like a lot of you have various experiences with Onshape. Some of you have experience with other CAD software. So I guess I'll try to go part assembly and maybe a little bit into drawings if that might help. So the main thing to keep in mind for electronics is that you're going to be doing a lot of importing, and I'll show you how to find the MKCAD library, which I'm guessing you're going to be using a lot. So with that, so a lot of you have a 3-button mouse. You can do some of this using just a regular mouse and some clicking, but if you need a 3-button mouse and you have a USB port, there are some over here. So the main things, Okay, so the main things to keep in mind are you have 3 planes when you're in your part studio, and you can use your middle bus to kind of drag around and your right button mouse to rotate. If you are unable to use those, you can also use these arrows at the top of this view cube, and you can also click on specific planes to snap to those. So we're going to start by making a basic electronics board. This is going to be entirely fictional. We're just putting arbitrary numbers in here. So we're going to start by going to Sketch, which is in the top left corner. And you'll need to select a sketch plane. For now, I recommend working with the top plane, or I guess in other things, whichever plane you know you're going to be oriented on. And you'll notice that now this sketch 1 window appears and that this dialog box is still here. Do not click out of this until you're done with the sketch. So for now, I'm going to click on top plane so that I orient myself normal. So now we have all these new features up here. We have lines, we have rectangles, circles. A lot of these are going to be useful tools for you. And I'm going to start by creating a center rectangle by clicking this down arrow and selecting center point. So now I'm going to click on the origin and I'm going to drag out until I have a basic rectangle. You'll notice that these numbers show up over here, and that refers to the current size of your rectangle. And you're also going to notice your rectangle is entirely blue. So normally when you get a blue line, that means that it is still relatively free to move in space. There's no constraints on it that are firmly holding it down, except for the relations that might already exist. So for now, I'm going to start by just creating some dimensions here. So I'll click on this dimension tool. Oh, by the way, your toolbars might look different based on what your aspect ratio is, but some tools like the dimension should probably still be there, roughly towards the right. And I'm going to click on this line on the side. You'll notice that now some of these lines are starting to turn black. That means that they're starting to get some complete constraints and full dimensioning. So for now, I'm going to say, let's just go for a 20-inch board. Okay, so now this length is defined, and we can define another length as well. So I'm going to define this one, and let's say I don't really want to do the math in my head. I just want to say that this is 3/4 of the length of one side. I can say 20 times 3/4, and it does the math for you. You can also convert from inch to centimeter by typing in your dimension in centimeters, and it'll convert it to inches for you. So this is a really powerful tool. So one thing I do want to make clear, there's a reason I had you start at the origin, and I'm going to show you right now. You don't have to follow this along. You can just catch up or watch. I'm going to go over here. So now, even if I define all of these, I still need to define its position to the origin. So I can just do this. I can define that, but it's still free to move in. Oh, hold on. It's still free to move in space. Yes, its size is completely defined, but I can still move it anywhere. You'll also notice that if I drag this down, a line might appear over here along with another black line that indicates a horizontal constraint. So I'm showing you this because it's a useful feature to have in Onshape, but it's also one that you might not be aware you're using. So do be careful when you're doing sketches. If something is highlighted in orange while you're drawing it, then you are adding a constraint without realizing it. So with that, you have your basic shape, and we're going to click on the green check mark and extrude it. So to do that, you're going to say extrude.
And you're going to notice there's new, add, and remove, as well as intersect and surface, but these are the three we mainly work with. I'll select the sketch we just made, and now you'll notice it's filled in. You'll notice that there's like a 3D shape you can look at. So I like to go symmetric for the first part I make, again, unless there's like a specific reason I don't want to, it's just a preference I have. And I can also say the thickness I want. Let's call it 1/2 inch. It's a thick electronics board, but it'll work. So now I can check that out and you have your first part. So there is one thing I do want to draw attention to. This is something I've noticed with this committee, and I've noticed it across other committees and even just myself when I'm having fun on Onshape. So you're going to have some parts that appear here, and it's going to be helpful to name them as you go, especially if you have multiple part studios going, and especially if you're going to have multiple instances of the part. Because I've seen some people who use multiple part studios and then they insert part 1 from all of those part studios, and then you just have a long list of part 1s, and you can see how that might get bad. So I'm going to right click and say rename, and I'm going to call this electronics board. I can also, if I wanted to, right click this and assign a material. So I didn't see any specific plywood material because it's technically not isotropic. There's a lot of differences, but I can actually pick any of these materials I want. So I guess for now, you can pick whatever you want. I'm going to pick balsa. I don't advise you use balsa. It's very easy to break, but you could. And then you can actually calculate its material properties, including center of gravity, including total weight from there. So while electronics is not normally the heaviest component of the robot, nor is it the one it's easiest to shave weight from, it is going to be useful in the long scheme of things. Another thing it's going to be good to know is, say, having a battery box on here. Now, again, this is a basic CAD tutorial. I don't expect you to do this exact method. I'm just doing this to teach. So I'm going to do another sketch. And this time I'm going to select this surface instead of one of the top front or right planes. And again, you'll notice that sketch 2 appears and that it's sitting this time on the surface of your board instead of on the origin itself. So I'm going to show you a little bit about relations here. We're going to make another rectangle, and this is going to be kind of a box for where the battery will sit. And I'm just going to click anywhere in space, just avoid orange for now, just to show you a few things. So this box will have the battery in it eventually. And for now, you'll notice that I can kind of drag it. And again, you'll notice that orange line kind of appear to add relations. So I'm going to sort of hover until I'm sort of directly above the center, and that's going to add a vertical constraint indicated by this vertical line over here in blue. So now if I move it up and down, it's not going to be able to go side to side. It can only go up and down. Another thing I can do if I wanted to is, say, set some of these lines to being equal length. So I can say equals, and then these two will be equal length. For now, our fictional battery is going to be square. I know our battery isn't actually square. That's, it's not. But for now, just for the sake of showing you equal, actually, we can break that. Yeah, we'll break that. So if you want to break an equal constraint, what you can do is, hello there. Thank you. All right, so you'll notice that when I hover over some of these lines, various constraints will show up. And you'll also notice that I can have 2 lines selected at once without having to hold down Alt. So be careful about doing that when you're in Onshape. It will sort of automatically select everything that you click on. And if you're trying to edit a specific feature and you have something else selected, you might not be aware of it. But let's say I want to delete that constraint. I can hover over the one I just made, click on it, right click, and then delete sketch entity. And now we're sort of free to expand this to whatever dimension we kind of want. I can lower it if I wanted to. Yeah. So now we'll dimension this again. And I think this time we'll go 3.5 by 7. And there you go. You'll also need to define its length from the origin because, again, we're vertical with the origin, but we can still move up and down. So we'll define it as, let's call it 6 inches from the origin. And let's actually make that a little bit bigger than 7. Let's actually make that 7.5. All right, so I'll leave you to catch up. This is where you should be. You should have a rectangle that is 3.5 by 7.5, and it is 6 inches away from the origin. vertical so it's not shifted left or right. I guess is everyone close or able to, okay, I'm seeing some thumbs, I'm seeing some nods, it's good. All right, so I'm gonna hit the check mark. And now I want to stay there for a bit. So I'm gonna show you something called the offset tool. Oh dear. So yeah, I can say offset, and then I can select these lines and kind of create this new shape going on the inside. And I can select the offset that I want. In this case, I want 0.25 inches of thickness, and there you go. It creates the shape for you. And now I'm going to extrude, and I want to show you something here. If I say add, and then I select this shape, it will create 1 inch in the same material, and it will still be part of electronics board. If you don't want that, what you'll do is you'll select new, and it'll create part 2 for you. Similarly, if you want this to be a cutout, you'll select remove. And yeah, it's that simple. Just remember when you're saying new, add, or remove. In general, in part studios, I'll make that 2.5 inches long and a new part. In part studios, you can actually have multiple parts, and I highly recommend you do that in cases where the geometry of the parts are all dependent on each other. If you have a part with really complicated geometry that kind of stands on its own, or if you're working on a project where, say, these are going to be parts that can be put together but won't really be, then you can separate it out. The main thing I would recommend is avoiding creating multiple files that are just an individual part in one part studio, and then you combine everything later. That can get to be a little bit hairy. So yeah, now you have a part. So we do also need to create a sketch for where our circuit breaker is going to go. And this is just going to be a sketch and maybe also some hole patterns, but we'll get to that. So I'll create another sketch here. And this time I'm going to do the same thing as before. I'm going to make a simple box. And I believe a circuit breaker is 2.9 by 1.8 or something like that. Does anyone remember the dimension? It's fine if you don't. I guess we'll edit this later if it turns out it's wrong. 2.9, I think it was, and then 1.8, I want to say. I guess if the center is what lines up, then that's fine. But I'm going to have this be, say, 6 inches from the center, and maybe, yeah, you'll notice you kind of have to drag it into place to get to the dimension you want, and 5.5 that way. So again, you'll be 5.5 inches to the right, 6 inches above, and I mean, honestly, just make a rectangle. We're probably going to have to change these dimensions anyways, and then hit the check mark. From here, we're going to leave this sketch alone because we're going to mainly use it to reference where we place the circuit breaker. And I'm also going to rename that part to battery box because again, we need to keep track of things. All right, so one other thing I'm going to show you now before we move on to the assembly is how to make hole patterns, because obviously your electronics board needs to mount to something and you will need to add holes so that it can actually align. So once again, I'll just go with a simple sketch on this plane. And this time I will, oh dear, this time I'll just create a hole. Actually, let's start with the center line. I'm going to add a construction line as indicated by this dash. And I'm going to start from the top and then move my way to the bottom. It's going to snap to the point where it will be vertical. And I'm going to dimension that line to be about 2 inches away. Again, this is a fictional electronics board for training. Please don't dimension your holes that far in. And then I'll add a circle right around here, and I'll make that about, again, we're going for a fiction here, so 1 inch. And 2 inches from the top. So we also want multiple instances of this hole. So we can either pattern this in the actual features tree, or we can pattern it here. I am going to go ahead and do a linear pattern here. And what I'll do is I'll select the line and, nope, I did the wrong order. I'll select the hole and I'll need to select a direction. So I do not want to go in this direction. So I'm going to say 1m. And I want to go in the opposite direction, and I'll say 5. I'll go down that way. It is a little bit easier if you do this in the features, but for now I'll stick with this just to show. Hold on. So then that's one way of doing it, and it'll create all of your holes. I'm going to Control Z that because that was kind of gnarly to watch. Hey, what's up? Of course. All right, so the question was how to create a construction line. So I'm going to go back a little bit here. Yeah, if I'm going too fast, stop me, and I'm really glad that you did. So I'm going to click on line, and then I'm going to click on construction. And the point of the construction line is it's a line that will be used only for reference within the sketch. This isn't, and I'll show you. I can click here and say vertical, click on the line, and that makes it vertical. I'll show you again. So if the line isn't vertical, you can go through your relations, click on vertical, and then click on the line, and it'll snap to vertical. So if you're not sure about the exact dimensions you want for your line, but you know what relations you want it to have, like you want it to be vertical or you want it to be perpendicular to another line, then go through your relations first. Generally, that'll also help you save time on setting dimensions. Does that make sense to everyone? Okay, I'm seeing some nods. All right, so I guess I'll move forward then. So like I said, for extruding a hole, you'll still click on extrude 3. You'll still click on either the sketch feature or the sketch itself that you want to extrude, but you'll say remove. Now, in this case, you can still have a blind depth and just have it be all the way through. But sometimes your depth might not actually go all the way. So like in this case, if I select a really shallow depth, I might just have a little indent. So I'm going to also say through all in this case, and that automatically takes you exactly the length you need. So again, you'll just do this with one hole, and you'll say through all and remove, and it will have this merge scope. So keep an eye on the merge scope for more complicated part assembly and stuff, because that tells you what way it's going to cut and what material it will cut through. So now, and I'm hoping this is a little bit cleaner because I saw in Sketch it was not very clean. We're going to pattern this with linear pattern. So linear pattern and some of the other patterns are going to show one sort of white shape and then 3 gray shapes next to it. So one thing I want to highlight is part of why I don't like using linear pattern in features if I can avoid it is because it always defaults to part pattern. And that means that if you click on this hole, it's going to try to click on the entire part and pattern the entire part, which is not what we want. So you're going to say feature pattern, and you're going to pattern this hole. And for direction, I am going to, let's see, it's been a while, but I'm going to select this direction. Nice. Then you can say the distance and the instance count. I'll say 5, I'll say 2 inches, and it'll create those going down. If I make them too close together, then it's going to turn red and it's going to fail. So that is a good litmus test, I guess, to make sure that it's safe. You can also add a second direction if you want, which we're not going to do. But actually, could we? Yeah, no, it gets to be a little bit weird, as you can see, but you could do it in theory if you wanted to. So I guess an application for this is if you want small holes for bolts going along the corners and sides of your electronics board, this could be a way to do it. For now, I'll get rid of the second direction because we're not going to do that. And yeah, that's how you do it. So the most common thing I see go wrong is a lot of times people will select part pattern instead of feature pattern. So make sure that you have feature pattern selected if you're patterning a feature. Another question that was really good is what if I want to say move the position of the box? So right now, this box is constrained to this position in the part studio, but it is not confined to that in the assembly. So if you want to move it specifically in the part studio, you can edit the sketch, and that'll you can move it however way you want or redimension it however way you want. But in the assembly, it's not going to be fixed to this position. So in the assembly, you can move it to even the other side of the board if you wanted to. Let's see, were there any other questions? I think one is be sure that when you're selecting things, you know when when a field is highlighted and when it's not. So in this case, one issue I did see was that, and this is something I do all the time, this is not to call any individual out. Sometimes when I'm trying to go to direction, I'll accidentally forget to switch to the direction dialog instead. I'll go here and then I'll select this line. And as you can see, that's, not great. So again, be careful. Oh, see, there I go. Yeah, that happens. So see, I did it just now by complete accident. It's something that very easily happens. And I guess it's just a general thing of be careful what you're clicking on in Onshape, because sometimes it will automatically select something for you or not automatically take you to the next field. And you don't realize it until you're getting something very wonky. Again, not to call anyone out, I literally just did it by accident. It happens to everyone. So I think at this point, there are a few more things I do kind of want to go over, but I think for electronics, these are probably the most important features. Mirroring might also be useful too, but we'll see if we have time for that at the end. I don't want to consume too much of your time, and it's already 11:34. So let's go to assembly. You'll notice there's a little thing that says assembly 1 right at the bottom. If you don't have that, you can actually just say plus and then create assembly. I guess I'll show you again how to do the offset. I'll just make a second sketch and show. So let's say I sketch, I can even do it with a circle if I wanted to. If I sketch a circle, I can click over here on this offset and then click on the circle and change the direction, change what offset or thickness I want to add. And yeah, that's all you need to do. It's a nice little feature to have in your back pocket, but again, you can achieve something similar by just sketching an additional circle at that thickness, or by extruding and then removing the material on the inside. Again, just showing you because it's useful. All right, so for the assembly stage, as you can see, there is a whole lot of nothing. As you can see, these tabs on the side are also different, including, how many of you have this MKCAD inserter tab right now on your assembly tree? Great, great. I do see 1 or 2 hands missing. For those of you who don't have it, do you know how to install it? Okay, great. I'm really proud of all of you. Yeah, generally I tell students if they don't have it installed, they need to have it installed. So let's start by inserting that electronics board you all did. So I'm gonna go to Part Studio 1, but I'm gonna specify electronics board. And now that just appears here. I can also insert battery box if I want to. Yeah, I guess I can do that now. And again, notice it's free in space. We defined its position in the Part Studio, but we do not have it set defined here in the assembly. You'll also notice that if I click here on sketches, I can also insert the sketches that we made. So that's going to be useful later for when we're mating a circuit breaker. But for now, we'll start with this. So you'll notice that these parts are still free to move in space. So some of you used SolidWorks before, and as you know, when you insert a part into an assembly in SolidWorks, it immediately fixes the first part in space, generally on the origin. This does not happen in Onshape, and that can actually cause some problems down the line. And it actually did cause problems down the line for the chassis yesterday. When someone mated something, the entire chassis ended up moving. And I think you can imagine why that could become complicated when you have a bigger assembly and now all your components are in space and your board's just out here somewhere. So we're going to start by doing a simple fasten mate here. So I know I've told a lot of you to avoid fasten mates when possible. Electronics is actually in kind of a unique position where, because of the kinds of mates you're going to be doing, and because you're doing a lot of components that are going to be possibly mated to sketches, you actually do have a bit more freedom to use fasten here. As a matter of fact, for mating a part to a sketch, I think the only way you can do it is a fasten mate. And generally, fasten mates are okay when it's the first part in an assembly. Otherwise, I would highly advise against it. So I'll start with here, I'm going to hide this for now. You can actually mate to the origin. So I'm going to start by mating to the top surface of the origin, and then I'm going to make this top part to it, and then it's fastened, it's completely rigid, it's not going to move, and it's confined to the origin. So again, to demonstrate, I'll just undo this to demonstrate again. You're going to click on fasten mate. Again, this is one of the exceptions to the avoid fastener rule. You're going to click over here on the top of this origin. It's going to create this flat mate connector. And then you'll click on the center of the electronics board and it will snap. So now we're going to do some mates with this battery box, and I'll show you here how to do some stuff with planar mates. This is generally the one I advise people to use if they can like avoid using a fastener. So let's do a planar mate. And first I'm going to start with their simple coincident mate. It's going to be this top surface of the electronics board and this sort of bottom surface of the battery box. Those two are now touching. They are completely flush with each other. That's what we want. But you'll notice it's still free to kind of move left and right. It can't move up and down, but it can move forward, backward, left, right, and its position is still not 100% defined in space. To do that, we can actually add another planar mate if we wanted to, and select, say, this back surface and this other back surface. Oh, hold on. I think I selected the wrong one there. Yeah. But you'll notice that it's kind of snapping to the center. It's not actually going to be centered. And you'll also notice that here, I'll just demonstrate. There you go. It's not actually, going through the middle of the electronics board, even if it seems that way at first. It's actually sitting on top still. Now we're still free to slide left and right. So we'll do one more planar mate. And we'll select this right side of the battery box and this right side of the board. But this time we actually want to have it a distance away. So let's have it be, click on offset, 3.5 inches away. Let's go the other way. All right, so we're going to have to go negative 3.5. And that's not quite, actually, no, it's pretty centered. That's good enough. And then once you hit the check mark, it will solve it for you. So now you have what honestly looks kind of like a clipboard right now, but it's a box. The box cannot move. Electronics board cannot move. Everything is perfectly defined in space. And if I don't like the dimension of this battery box, if I want to change that, I can edit the planar mate and change the offset in the Z direction. Now, this is another question that a lot of students have, and it's one that the mentors are honestly trying to figure out as well. I believe the Z that it selects is generally just sort of a local Z. It's not necessarily the XYZ of your actual space, because, this is Z going up in this case. So try not to let that confuse you too much. This Z and this X are not global X and global Z. They're just sort of, I honestly don't know why they use that, but they do. All right, so does everyone have something like this so far? I think I briefly touched on this earlier. So let's go to extrude 2. I'm guessing that's everyone's battery box, right? So a lot of you might have selected add instead of new. And what add's going to do is it's just going to be part of electronics board. It's going to be fused. It's not going to move around in space. Clicking new is going to have it become its own part. And that is how you can set a different material. That's how you can have it move around freely in the assembly. And yeah, it's just something to keep an eye on because, again, when you're making multiple parts in a studio, you might momentarily forget that you didn't select new. So keep an eye on it. This is going to be a really common mistake, and it's one I made when I was making this workshop. So yeah, it's going to be very common. So normally CAD cares about the order in which you do things. So if you want to reorder, you can actually click and drag both mates and features around to change the order in which you do them. It doesn't always end up having a changing outcome, but there are certain times where I would argue you want to do sketches in a certain order, let's say, like if you're referencing one sketch to another. So with that in mind, we actually need to add in the sketch for our circuit breaker, and we need to add in the circuit breaker itself. So to add in the circuit breaker, I'm going to go to MKCAD. Once it loads, there we go. And I'll click on electronics. And let's go to, I'm going to go to the simplified circuit breaker, main breaker for now, because I mean, we can put the full one in. I just prefer working with the simple one in this case. And once again, it'll insert to the center, but it'll be free to go wherever it wants. We're also going to go to insert, and we're going to click on right over here, sketches. Pay attention to this because this is going to be something you use a lot. And we're going to insert sketch 3. This is the sketch we created to be the placement for our circuit breaker. And yeah, it'll kind of snap to the position we want, which is way too close to the battery box, but again, fictional board. Now, the thing about sketches is they're similar to parts in which they just sort of float in space at first. So we're going to need to fasten this one as well to the board. Again, we'll use a mate connector fastened, select the center of the sketch, select the center of the board, and it'll snap to place. Oh, I selected mate connector by accident. So again, fasten mate, center of board, and there you go. And you can also do this for your main breaker. Again, this is going to be one of the exceptions to the no fastener rule. This is a case where there is no real robust way to mate a part to a sketch. In SolidWorks, you can select an individual line and make it coincident, and Onshape, unfortunately, I have not been able to do that. So you'll select fastened, you'll select the center of the sketch, and then you'll select the bottom of the main breaker. And that is how you made it to the sketch. From here, we're going to add holes to the board by editing in context. And I'll show you how to make sure that when you edit in context and then change the position of the breaker, the holes will move with it. Because talking to Dean, it seems like that's one of the bigger issues that you're going to have. Let me know when everyone has a main breaker. So now for the moment that you've all been waiting for, I hope, we're going to be doing an edit in context to add some holes to the main breaker area. So I'm going to start by right-clicking on electronics board. Make sure that you're not selecting the sketch by checking that it's highlighted here. You're going to right-click and you're going to say edit in context. And now you'll see a few things. You'll see assembly 1 displayed, but it's going to be in the part studio. So you can actually make it a bit more transparent if you want. You can hide it if you want. Either way works. I like to have some level of transparency, but still be able to clearly see the parts. So this is good for me. I'm going to say sketch, and we're going to do the top of the board as our sketch. And what we're going to do is we're going to do some projecting. So I'm going to say use projector convert, and I'm going to select the holes of the main breaker. Great. So now I'm going to actually use something called the hole tool. You can also do an extrude and remove if you want. That is completely up to you, but I'm going to show you the hole because this will allow you to put in custom bolt sizes. So let's say you know for sure that for a main breaker, the bolts you use are going to be M6. You can go over to simple. You can select ISO or ANSI if that's what you're using. ANSI is going to be like 1/4 or number 8, 32, things like that. I'm going to select M6 from ISO, and I'll just put in a number of some sort. I think I put in 30 millimeters originally. I'll just put in like, yeah, I'll put in 30. Not 30 inches, 30 millimeters. And again, it converts it for you. And sketch points to place holes, you'll select the points that you made from the convert. And if you did your job properly, you'll see the holes emerge from the other side. And if you hit the check mark and go to assembly, the holes will be there too. I think we're probably going to break for lunch soon, but there is one thing that Dean was wondering about as well. And I think, I'm not sure if Samra was the one who posted the document. It was a document about editing context. This is going to be something to add to this. So this is mostly for demo purposes, but you can do it as well if you want. This sketch is what I use to reference. Yeah. So it was sketch 3 for me. I'm going to edit that. And I'm going to make this now 4 inches from the bottom. And oh, also assembly context is here as well. That's useful. Now over here, the main breaker moved down, but the hole is still over there. That's not great, right? But there's a way to fix that. I am going to right-click electronics board. I'm going to say update context, context 1, and the hole's moved. So if you're doing electronics work and you need to move the placement of one of your parts, you need to update the context. Otherwise, it's not going to move. The holes are going to stay there and you're going to be a bit confused, which is fine. I think we're all a bit confused. So yeah, we've done some edits in context. We've done some fastener mates and some planar mates. We've used MKCAD. Where else can we go from here? The answer is we can make drawings. So this one, I don't expect you to do. You can try to follow along as you can, but you're not going to be doing as much of it for electronics. You can create a drawing. And we'll do ANSI 8-inch. ANSI and ISO are basically just standards for mechanical stuff. ISO uses English metric units and ANSI uses American units. Okay, so I'm going to take electronics board, and you'll notice I can kind of click anywhere and it'll sort of generate these sketches. What it's doing is it's creating multiple views, including a projected view if I wanted to. I don't know why you would do that for an electronics board, but you could. So part of why this is useful is this probably looks familiar to those of you who have seen the laser cutter, right? You have a 2D sketch. So you can use the drawings to an extent to help generate 2D sketches. As a matter of fact, you can actually insert a DXF if you wanted to. And I believe you can also export this as a DXF if you wanted to as well. That way you can send this to a laser cutter if you wanted. So one thing I do want to highlight is you can add dimensions here, and that will tell you about the dimensions of this. You can put it into your CAD journal, you can put it into a design report. This will tell you how big the electronics board is. You can also do custom hole callouts for these guys, and I would actually advise you to do that. So for this guy, it's a 0.260 through. You can even modify it and add a note saying that it's specifically an M6. Or maybe you can say it's like tapped or something like that. Generally, I would advise you to do that if you have a lot of holes. In your case, because you're going to be doing a lot of laser cutting, you probably don't have to do that for every single hole. As a matter of fact, I would actually advise against it because this is going to be full of holes. But that is something that might be useful for you to know, especially if you have a custom electronics part. Like you're making your own battery box, right? So you might actually want to have drawings of your battery box parts. If you make any custom fittings, if you make any custom brackets, I would try to create drawings of those as well, because putting a lot of effort into your electronics design is something that judges do like to see. Especially judges who are at Cal Games who inspected your robot and specifically said that he really liked the electronics board because he thought it was well designed and well thought out. So yeah, I guess I'm just telling you that because the electronics team is a good team. All of you are doing really good work. And I know that Onshape is new to a lot of you, and I know that it's kind of difficult to learn. The mentors are still learning with you, as evidenced by me not registering that context 2 was a thing. And if you have any questions, be sure to ask us. Again, I'll upload all of this recording with all the dead bits cut out to, I'll upload it to Slack and you can see it. I'll put it on YouTube. That way I can like add timestamps to it maybe. I guess before we conclude, does anyone have any questions about anything whatsoever? Anything we went over, anything we didn't go over? Applications, what's the point of all of this? Anything? Okay, I'm seeing some shaking heads. Let me ask you this. Is there anything else you would have liked to learn about today? Okay. I guess one thing I would recommend to all of you is get comfortable with the Part Studio. There are some features that you might use here that I didn't really go into, like the mirror tool. Let's say you have a perfectly symmetrical electronics board, or let's say you have one talent on one end, one talent on the exact opposite end. You could even use things like, I mean, you could add text if you wanted to. You could, I mean, you don't really need to fillet things, but yeah, there's a lot of features that you can explore that I would recommend looking into. One in particular that you might have fun with, your electronics board isn't going to be blue. You can right click it, edit appearance, give yourself a red electronics board. I think that there's a lot to explore in Part Studio, and I think there's a lot to look at in assemblies that you can get comfortable with. And you can even create variables if you want to. So I would recommend, if you do not have anything whatsoever to do, which no, the electronics board, electronics team stays busy, you have plenty to do. But if you have absolutely nothing and even the mentors are unable to give you a task, take out Onshape and see what you can learn. Get comfortable with it. And again, if you have any questions about Onshape, there's CAD General, there's Electrical General, and there's also questions for mentors. So you can access mentors or even other students through all of those means. And I recommend you do that when you're learning Onshape. And again, keep water on hand. I get dizzy when I'm doing this, and I'm sure I'm not the only one. So yeah, that's the workshop.